Hi, in this series of videos I will explain Matlab and Python codes of our paper on joint design of analog beam selection and digital precoder design, digital precoder in millimeter wave cell-free networks. So we have 5 algorithms here and one more algorithm in the next page, which I will mention. These are joint designs. So fundamentally we have 2 algorithms. One is linear, the other one is semi-linear, which is more complex than linear. So IIS stands for initialization, iteration, and selection. And these algorithms are based on sum rate metric, whereas this algorithm is based on direct link powers. And the last algorithm is the naive version, which doesn't have any joint design. And another algorithm we have is here on this page, which doesn't use beam conflict control. So in total we have 1 here and 5 here, 6 algorithms for a joint design. And then later we will use these outputs to train machine learning algorithms. We have the results of them here in the next page. We have a regular SVM, we have Gaussian SVM, and multi-layer perceptron random forest algorithms. I will talk about them later. Let's go through joint design algorithms first. So here is I would like to start first our folder structure. So I suggest you create a folder called Matlab, and for myself I created a subfolder shared, which is different from my original codes. So you can follow the same structure, not to change the codes. So under this shared folder we have 3 main subfolders relevant to this paper. These are machine learning algorithms, which we have AI here instead of machine learning, artificial intelligence. We have joint design algorithms here, which is named as beam selection. And we have generator folder here, which is used for generating random variables for simulations. And here we have a very short introduction about this paper and the codes. So this time I decided to have videos instead of long documents, which still may not be very useful compared to having a video. So this is the joint design algorithm folder. So you can run as many instances as you like. So if you want to run multiple instances, you need to copy these and write down code 02, 03, 05, and you can run them at the same time. So the outputs are logged in here and the results go in here. So the results go in here as zip files, and the main results go in this Excel file as text files. So when you have multiple folders, your zip files will be copied to code 01, but your output XLX files will be written in each subfolder. They won't be written here because they will conflict. There will be a runtime error if we do so. So as you see here, we have 6 algorithms. So basically what I do usually is I start with AI, BI, CI. So I will also make a note about this. So usually ABC means different algorithms, I means some major change, and version 01, 02 means some minor change, and maybe version 02A, B, C is more minor changes. and I keep a log file for these algorithms in Excel, which I just realized I didn't prepare. I have my own, but I didn't prepare for this. So which can be something like this. If you go to our own code, is here. So you can create the function name, version, date, and explanations and other things, so you can easily track your codes. Okay. So when we open that, so right now let's change the directory, not to make it confusing. Okay, now these are joint design algorithms. We have a runner file. This calls main file, and main file calls the algorithms you want to execute. Joint design algorithms. So runner algorithm checks which networks we want to test. So the networks we want to test are here. Under generator folder. This is the networks we want to test. So I suggest using Libre for this network list, so that when you execute, it won't tell you to shut down Excel files. When you have Microsoft Excel, it will ask you to shut down, but if you use Libre, you don't need to shut it down. Since you might need to do a lot of executions, you want to keep this Excel file all the time open. So you can write down the algorithms you want to test. Here, how many Monte Carlo runs you want to have, number of access points, users, number of antennas at each access point, transmit power, number of installations, iterations. This grouping is not in use, it's black. And these are the runners. So we need to choose our runner. So we want to execute code 1, so we choose 1. So then when we execute this Matlab file from here, like this, it will go check that network list, and it will see, okay, I need to execute this network setup. And they are listed here. So these four are for machine learning algorithms, and their correspondences are here. And these are for joint design algorithms, and their correspondences are here. So to keep this video short, I won't go into full details. I will try to explain the most important parts. So if you want to test multiple network setups by the same Matlab instance, you can copy this, paste, you can change any of these variables, and you keep this number 1. So if you want to have multiple Matlab instances, all you need to do is copy this folder. You can create a base folder, so you can delete these results. And this is your base folder. You can, if you want, delete any existing results here. So this is your base folder now. So when you want to have multiple Matlab instances, you can just copy paste this base folder. Then you need to change this runner. This is runner version 1, and you want it instance 2, you make this instance 2. So when you want to run 2 Matlab instances, you need to create it. Let's say just 5 Monte Carlo runs, and you want to execute instance 2. So then you can run at the same time. So what will happen when we run it? First, the algorithm will check if we have random variables are available or not. So I won't go into the details, but I think using fixed random inputs which seem contradictory, but I usually generate random variables and I use them for all algorithms to a fair comparison, and this way I don't need to run many Monte Carlo runs and it can still be fast. Before I was thinking maybe this approach, because of reading files, might be slow, but I realized actually this can be still fast if the network size is large. Anyway, this is I'm not so sure yet, but what you can do is until you're sure, you can have fixed inputs to be sure of your algorithms. When you want to run the final results, you can just create those random variables on the fly, not read from the text files. That's also possible. So this is the generator Matlab file. Great. Okay, so this is the generator Matlab file. So it will create us the random channels. Also, it will create random analog beam index initializations, and also we will have some powers which will depend on channel model. They are all here. I won't go into the details. And this file will also generate the feature vectors. As feature vectors, we are using angle of departure and its power. So I am not using rate actually. So these are other trials I did, which I didn't delete. But basically, this work is using two features: the direct link power and angle of departure. It will also create those feature vectors. And also those random indexes will be created in two versions. One with beam conflict control, one without beam conflict control. So I'm not mentioning about what is BCC, beam conflict control or not, because the intention of this video is to introduce these codes, how to run these codes. As an example, we can try maybe just 5 instances. Maybe we can try this 15, because as far as I know 15 has not been created yet. We can make this screen small. I will stop here. So we have now 2 Matlab instances. This is code 02, as you see 02. This is Matlab instance 1. So let's run the most simplest joint design version, which is AI1. So the first Matlab instance will test let's make this 20. We'll test 2 network types. In this case, we have same network type but different Monte Carlo runs. Let's make this 4. The second Matlab instance will test only one case. And another important thing is we need to add the paths. So we have 2 libraries. One is under beam selection folder. The other one is machine learning algorithms folder. So we need to add these folders, these 4 of them, to our paths. So when we run these codes, we can run these codes at the same time. I did tests before recording this video, but while doing those tests, although I already knew, I didn't remove those old paths that I had. So I noticed that there are some missing sub files. When I removed those old paths that I'm originally using, I could see that I have missing files in the new version. So if there's any problem, it's a very minor problem, let me know. It's very easy to fix. So I could run two Matlab instances at the same time, and I will do it again. So for the first network test, there are already existing random variables in this location. Since these random variables already exist, it doesn't need to generate, but for the second network setup it needs to generate first and then execute the algorithm. For the second instance, similarly, there was no available random variable, so it generated first. And to do the same, I just deleted these files, so we will see the same results when I execute these instances again. So it's working for this instance, and now it's working for this instance. Since we have a very short number of Monte Carlo runs, the results come up very quickly. So instance 2 has been completed, instance 1 has been completed. I increased the resolution so I cannot close it. Okay, so the same wise we can do the same for other algorithms. We can just choose this one, that one at the same time. We can have 6 Matlab instances. If you would like to have more Matlab instances, we have here run me version 6. We have 6 tabs, so if you want to have more Matlab instances, you need to copy paste these instances and just rename it as code 07 and etc. So these yellow colors are being input from network list file, because these are the main parameters that in the paper we change, and these are more fixed parameters, so they are here. If we want to change, we can change those parameters from here. So it's good to divide the variables into the ones that are being often changed and the ones that are being less often changed. So just as an introduction, just to explain simply, to generate files, it dumps those files in here first, and then it after it's done, it moves those final results to these locations. And as you see here, beam selection code 1, we have results of all of them. So the results from code 02 are being copied here, but as a text file they are within their own Excel files. So this is output version 01 that belongs to instance 1, but the result to instance that belongs to instance 2 is not here. So we can copy just opening that instance, you can open it with the Libre, or you can copy paste and rename the file, so you can open at the same time two the same names. So this is a summary for beam selection codes. So after we are done, okay. So now we are ready to generate training and test data for machine learning algorithms. As a simplest case, I generated 30 Monte Carlo instances for training and 10 for test purposes. It was one here, so I generated these data on MATLAB instance 1 by using the second algorithm, just to test while making these videos, so it worked. So they are generated, and now we can execute our MATLAB instance, our machine learning instances. For machine learning instances, for machine learning algorithms, we have 4 algorithms which are here. Linear, normal SVM, Gaussian SVM, MLP, and random forest, 4 of them, and these are slight other different versions, which I won't talk into the detail too much. So in Python language, the codes are less well written, still good, but less well written. I mean, well written, not well written in this respect. It's less automated, and MATLAB also actually not full automated. In fact, there are many controls. Many controls are not available in MATLAB and in this Python. So normally there should be some controls. The file existing. The name is not in the list, so please put these simple simple checks are very good for the user, but unfortunately I didn't add those things. Maybe it won't take much time, but I didn't add them. So it's a bit many of things are required. So these are the paths of the Python codes. And here we need to write down some manual entrances. So this is Beam's selection algorithm. So if you want to input the Beam selection algorithm B1, A1, we need to change it. Since I tried algorithm B1 as a Beam selection, I put B1 here. And in the paper we use Beam selection algorithm D1, which is joint initialization iteration based on rate metric under BCC. So D1 for the paper results, but for tests I put here B1. So then we can run any of these algorithms, and we can look what those algorithms mean. Here is the list is here. A1 is linear SVM, B1 Gaussian SVM, C1, D1, MLP, and random forest. So to run that machine learning algorithm, we choose from this menu. And Monte Carlo number must be the training number, because it is based on the idea that training to test data ratio should be 3:1, which can be adjusted somewhere in the code, which is here. We can adjust it here. So when we choose this option as a ML algorithm and we execute, this is the output already. The best score, the best parameters. The parameters are here. AI is LSVM, so the parameters are here. There's no search actually, I just set some parameters here. You can do a search by trying multiple options. And since right now we are using a chain classifier, we need to have this pre-extension of in front of the name, and to see those parameter names exactly we need to check with this. What parameter, because we have wrappers, as we have more wrappers, the parameter names get longer. If you don't use a chain classifier wrapper, but if you use multi-output classifier wrapper, which will give you worse result than chain classifier, as explained in the paper, if you use multi-output, you don't need this pre-extension. So when we execute this one from here, accuracy of this algorithm is low because the training and test data is very low. it will run and it will test. Many framework is same with the Matlab codes. Even the outputs are very similar. And again, the logic is same. This is the algorithm. We have a library, we have results and zip results, and we have Excel results. So I did these tests before, as I said. So the results go in here, and these columns will be filled in Matlab algorithm, because now our machine learning algorithm did some decision on beam indexes. Now we need to run another Matlab algorithm which will take those beam decisions from machine learning algorithms and which will give us the rate. So we can compare the rate obtained by a machine learning algorithm and the rate originally obtained by beam selection algorithm. And the results go in here. So I ran a pure instance. I didn't change the variable. So since it is 3-to-1 ratio, the training number must be divided. Can be divided by must be divided by 3. So we can delete this. So as you see, the outputs are here. So you need to look into the details, what's going on. You need to look at the details of the code. So now we need to run another Matlab instance, as I said, to find the sum rates. Now we can run another Matlab algorithm to find the sum rate based on the decisions of machine learning algorithms. So these codes exist in AI subfolder again, code 1 subfolder. It has a similar logic with all other codes. And again, unfortunately, it requires some manual operation. So since we chose this beam selection algorithm, we need to change it from here. And if you want to try, if you want to find some rate of AI, BI, or CI machine learning algorithm, you also need to change from here. And to run this code, we need to choose one and make all others 0. And the Monte Carlo number must be again the number of training data. So again, it can be adjusted here. We are assuming it is 3-to-1 ratio. So basically, this is how it works. Now it will evaluate the original sum rate result and the sum result based on machine learning algorithms, and it will fill in. I want to open with Libre because I have a problem with Excel. As you see, these empty sections are filled in. So one thing that the user must be careful about is the logic is like this. It is best you execute your random forest algorithms, your machine learning algorithms, and those machine learning algorithms results will be written here one by one. Yes, you can do that. You can do that. It's up to you. But what sum rate evaluation program does is it writes only on the first line. So it always writes on the first line. It doesn't go find the next empty row here and writes there. While all other codes you have seen, they fill up the next empty line. Only this sum rate evaluation Matlab file writes on the first line. So you need to be careful about this. As I said, many things are manual. Just the most important things are not manual, such as you want to write the result in a good way here after running, maybe waiting 1 hour. So you want to make sure this Excel file is closed and can be accessible. So the algorithm checks that, but for instance, it doesn't test, it doesn't give you also the dialog box saying that let's say you wrote G1 by mistake and G1 is not here. It won't give you the necessary error warning, so you have to find from the codes. Similarly, so one of the most important things are checked in the code. So this is basically how the process is being achieved to get all those results in the paper. There are some unused things in the code which I didn't remove for the sake of not introducing bugs. I think introducing bugs will be more dangerous. But if those redundancies are removed, the codes will be run faster. For instance, there are here some unused feature vectors. They can be removed easily, and the code can be run faster. For instance, this is useful, but this is also not useful. Sorry, none of these rate features are being used. Only, as I said, direct link power and degree of departure, angle of departure features are being used in the codes. For the final remark, these Python codes can also run on two instances. It has the same logic, so you need to copy paste this code, make it 0, 2, and change this 1 to 2, and also you need to copy paste code 1 and rename it as code 2, and same here, you need to change this last number 1 to number 2, and you need to choose 1 here and 2 here, and make both Monte Carlo runs as the number of training data. Yes, the random forest algorithm obtained the correct result in the given time. I was just testing if any file missing or not. You can try these other grid search CV library, hyperband search CV library, but you need more ramps. It won't work on normal desktop PCs because they make the searching faster, but you need more RAMs. However, I used Dask library. I can choose how many logical processors I want by using their library, and I usually chose 8. We have on this machine 6 core processors and 12 logical processors, so I chose 8 logical processors, and you can run it. I think usually I run it once and then it's done. You don't need to run it multiple times, and then it will take like about 2 minutes. If you don't use it, it will take about 5 minutes with these parameter sets. So yes, this is all about Python codes. There are more details, but they are hidden in the codes. These are the locations of the algorithms, machine learning algorithms, and parameters are being pulled from this file, whereas the training and testing they're being issued in this file. And we can change classifier chain, multi-output classifier chain, one versus one or one versus rest classifier, they're all here. As a last comment, we will find a beam searching results. If we go to beam selection folders, and if you go to DI, which is a linear joint design with multiple initializations, iterations based on rate metric under BCC with 0-force digital precoder. These are two important cases, L3K2M8 and L3K4M4 cases. You can find 30K and 10K results. Basically, these were generated based on my uncleaned codes. So you will find a lot of things here which you don't need to know. Basically, we need the outputs of these zip file to train the machine learning algorithms. But anyway, I put the whole zip file here. When we run the machine, so based on this DI beam selection algorithm, we can run any machine learning algorithm. This one is RF, this one is LSVM, GSVM, and MLP. So basically, if you look at, for instance, random forest results, it will create another zip file and put the results there. Here, for instance, you can see, but mainly, of course, this output file or the output file here, you will find those results. So in the paper, we explain why these two cases are important. So since I didn't want to wait another long time with the cleaned up codes, I just used the old results. So if you want to generate a 30K to 10K or any other ratio, you can create those training and test data by using any beam selection joint design under these folders.